Hey everybody, welcome to a new video. In this video we are going to talk about jit.gen and we are going to describe all the functions that we can find inside the jit.gen programming environment. And which is the same, by the way, as the jit.gl.pix programming environment. So we will work with the jit.gen object, which has this programming environment inside, which is the same, by the way, of the jit.gl.pix object. They share the same kind of gen programming environment. So I have already quite some videos about jit.gen, especially starting with this jit.gen series here, jit.gen 1, jit.gen 2, and I arrive up to jit.gen 4, I think. But as some of my patrons suggested me, I think there is still a missing link here, which is kind of to describe the functions inside the jit.gen in a super basic way and showing what they do without adding some more complex layer on them. So yeah, this is what we will do in this video. So first of all, let's create a Jit Matrix, which we need to trigger an output from our jit.gen, or maybe let's use a Jit movie object. Button 0. So we can either work with the video material or we can work with some generated material. So in this video we will start by seeing how to apply gen functions to matrices, to video, to images. And then if we have some time we will see how to apply this to three-dimensional shapes, or maybe we will do that in another video. So I created a Jit movie object. Let me get a video here, like the ball guy. Let's create a Q metro 33 active one to trigger our output, and we should see our video here precisely. So first of all, let's note the dimensions of this matrix that comes inside. We can do this by using the jit.fps GUI object. This is the jit.fps GUI, which allows us to see the dimensions of this matrix, the plane count, and the type of the matrix. So this matrix is gonna be of type char. Now, we could actually prefer to work with a matrix of type float32. I think this makes things a bit easier. So to do that, we can create a matrix here with 4 planes. So we give to this matrix the same properties of the movie matrix. So 4 planes, path of type float32, and then dimensions as the incoming video. So now we have in output, we have now as an output a matrix that is in type for float32. So let's put these things in order. 4 planes, type char, dimension 320 by 240. Okay, this is jit.fps GUI. While if we check the matrix as an output, we will see that it has the same dimension, same planes, but is of type float32 this time. Okay, so because I think it's preferable to work with float32 type. Okay, so let's go inside jit.gen and start to see what we can, which functions we have available inside jit.gen. So I will start with the functions that I use the most. So one of the functions that I use the most, or one of the objects, so I use the word functions and objects kind of interchangeably in the context of jit.gen, because basically every function, every object contains kind of a simple function. And also because we can find these functions inside the code box environment, so in which they are proper functions. So when I say functions, you can think about objects or functions. It's the same. So if we connect this snorm object to the output, what we see is this. So why do we see that? We see that basically there is a gradient of color going from black to red on the y axis. So let's take actually a look with the jit cell block object. So let's do it in a way in which we can see all the numbers at the same time. So let's make the default column width a bit bigger, like 120 maybe. Cool. And let's give it the message plane -1, which will allow us to see all the planes at the same time. Okay, cool. So as you can see, we have a series of numbers that go from 0 to 1, on the y axis of this matrix, on the y dimension of this matrix, for all the columns. Okay, and we can see that if we check the first plane though, we can see that we've got numbers going from 0 to 1 on the x axis. So why don't we see them as a color inside this JIT window? That's because they are on the alpha channel. So if you remember, the first channel in a JIT matrix is the alpha, which we actually don't see. And then the second channel is the red, which we are seeing. And this channel is filled with coordinates going from 0 to 1 on the y axis. Right? So what if we want to see also the x coordinates? We could, for example, use the back object. And you can think about the back object inside jit.gen in this context a lot like as the jit pack object. It's basically very similar to the jit pack object. It takes a bunch of planes inside and it outputs them as a single output. Okay? So you have to think about every one of these inputs in the back object as a different plane in the matrix that we will have as an output. Okay? So every input of the back corresponds to a plane in the output matrix. If we connect this to the output, okay? So if we do like this, we don't see anything because the matrix is all full of zeros, so all black. But for example, if we fill this with 1, we can see that the red plane, so this is alpha, red, green, and blue, we can see that the red plane has been filled with the number 1 for every cell of the matrix, which means we see the color red. If we set a 1 here, this will be yellow. If we set another one here, this will be white, because the sum of all the colors will be white. This is blue plus red, and so on, right? So if we want to visualize the x coordinates and the y coordinates as well, we can use the object swiz. So what does the swiz object do? It's basically a lot like the jit unpack object, or simply the unpack object. It takes a single input and it outputs different channels from this input. But what the difference between the unpack object, so the unpack object is like of a passive object that takes an input and it will just unpack it in several outputs, while the swiz object basically actively grabs a component that we are requesting from the input, okay? So this grabs the first plane or channel, depends how you want to call it, of the input. So we know, if we look at the help of the norm object, the normalized coordinates of input matrix 0 to 1, we know that the norm object contains 2 channels if it gets a matrix with 2 dimensions as an input, like this one here, 320 by 240 is 2 dimensions, then it will have inside 2 channels. 2 channels because input matrix has 2 dimensions. Right? So since the input matrix has 2 dimensions, the norm object will have 2 channels, and we can switch those 2 channels, so we can basically actively grab one of the 2 components using the swiz object. Now the swiz object takes an argument, which is basically the plane or the channel we want to switch. And we can use, for that, we can use x, y, z, and w, or we can use alpha, red, green, and blue, or we can use numbers that go from up to as many channels we want to switch. Okay, so we are using x and y if we want to take the first and the second channel inside the norm, but we could as well use swiz 0 and swiz 1, and we could as well use swiz A and swiz R. This will be exactly the same. In fact, if we try to connect this to the red, we can see that we got the x coordinates going from 0 to 1 in the red channel, right? Then if we take the y and we connect it to the green channel, we can see that we got the y coordinates going from 0 to 1 on the y axis, so on the vertical axis. And in the end, here they create the yellow color, because red plus green becomes yellow. But we could, for example, connect this to the blue, and then we would have red and blue forming here, creating here the purple color. Okay, so we can use width A or R, we can use width X or Y. This is exactly the same, or 0 and 1. So these are the three possibilities we got to swiz stuff inside Gen. There is even one more possibility we have got, which is not to use the swiz object, but to create an expr object and to say norm.x. Now, if we connect this here, this will be exactly the same. So we could say norm.x, we could say norm.a. Can we say norm.0? Not sure. No, this doesn't work. So norm.x and norm.a will work, which is basically, it means we are creating an expression, which means an expression is like if we are using the code box object. So it's basically we are creating a little coding environment inside this expr object, and we are outputting the value that we are using as an argument. For example, this could be even an expression, in fact. For example, we could create some mathematical operations inside this expr object. But we can also use it just like this, to say get the norm object, and from this norm object, which is a container for these two channels, take the channel A or the channel X, which is the same. This will not work if we will just write norm.x, this doesn't work, but if we put this inside an expr object, then we can have it like that. Okay, so the expr object is another object that we can use to kind of make expressions on the fly. Okay, so this is the norm object. It simply contains coordinates that go from 0 to 1 and basically are associated with every cell. So every cell will have its own coordinates going from 0 to 1 for the x or the y. If we would have a one-dimensional matrix, then this would have only the x coordinates, because there would not be any other dimension, so it will only have the x coordinates for the cells. Okay, since there would not be any y cells, so it doesn't make sense to have coordinates for the y cells, so that's why the swiz y is basically empty. Swiz 1 or swiz y is basically empty. So let's go back to 2 dimensions. Okay, very cool. Now there is another object that is very similar to norm, and this object is snorm. The snorm object is an object that gives us also coordinates between 0 and 1, like the norm object. Let's actually write this down. Coordinates between 0 and 1. Let's actually use the bubble message thing, which I like a lot. So this is valid both for the norm and snorm. They will have 2 channels because the input matrix has 2 dimensions. The difference between the norm and snorm is that snorm is signed normalized coordinates. So the coordinates will go between -1 and 1, because they are signed. So they will go between -1 and 1. In fact, if we swiz snorm instead of norm, we can see that the first part of the coordinates here, the first quarter here, is the quarter where the coordinates are negative. As you can see, in fact, they go from -1 to 0 in the center for the x, and then they go to 1 on the right. Okay? While the y coordinates are negative on the top, and then go to positive. They go to 0 here on the center, and then they go to the positive on the bottom. Okay, so this is exactly like the norm object, but it goes from -1 to 1. And we can swiz as well x and y. So these are 2 of the most fundamental objects inside the jit.gen. Now, let's see some other object before we round up with this video. In fact, I think we will keep it short. So let's see another object before we close. So let's see, for example, the absolute object. So absolute object is a very useful object. It's very simple. It basically transforms negative numbers into positive numbers. It's very stupid. We have this object also inside normal max, called abs. So what it does is simply to get the positive version of a number. For example, if we have the number -10, this will be 10. And positive numbers aren't changed. Negative numbers just become positive. Okay, super simple. So, for example, if we put this in between the swiz and the vector object, we see that we can see the negative values as if they are positive. And if we do the same with the epsilon, then this will be the same for the epsilon. We see the negative values as if they are actually positive. So they actually become positive values. Oh, and I forgot to mention something very important. In Gen, we don't have float numbers, so we don't have to write abs 0, for example. This actually changes the behavior of the object. In Gen, everything is float. So, in Gen, everything is float. And everything also has auth inputs. So if you check all these objects, they all have auth inputs. They don't have like they don't have cold inlets like normal max objects. For example, the pack object, which has cold inputs. In Gen, everything is an auth inlet, which means everything virtually everything in Gen happens at the same time. So virtually everything in Gen happens at the same time. Now, why I'm saying virtually? That's because in a computer, it cannot be that stuff actually happens at the same time unless we are working on the GPU or we are working with multiple cores. So in this case, actually everything happens one thing after the other, but we can imagine that for what we are concerned, we can imagine that it all happens at the same time. So I don't have to be worried about if this object goes first than this other one in. Everything is happening kind of at the same time. Now, just to add a little thing on our jit.gen overview, that you can see here on the side, if you go here in code, you can see basically a code box representation of what is going on in our patch. So if there is this object called code box that we will see in the next videos. And in the right of the window here, if you go into this code thing, you can see how this would look if it was written in code box. Okay, so yeah, definitely we didn't manage to see many objects inside these videos, but I want to keep it short. And I'm definitely going to do a lot more videos about this, because I think this is this is the missing link between starting from zero and all my tutorials that are a bit more advanced and work with jit.gen. Okay, so if you have some comments, suggestions, feedback, please, I'm very open to that. And if you want to have a more direct contact with me, you can join my Patreon, and you can join the Discord channel as well. So Discord is kind of a server-based chat application in which I have my little server with a kind of a growing community, like at the moment around 100 people. So yeah, it's a very nice place. There is a lot of jitter stuff being discussed all the time by me or by the patrons. So join the patrons for that, and to get a lot of patches for jitter. So enough with the self-promotion, although I always have to do it. And see you in the next video. Thank you for following. Ciao, ciao.